Often what you think of is the domain are the x coordinates, the input values. The range is the y value, the outputs. Okay, so the domain is just the set of all values for which any expression is defined. Okay, so when you identify domains, often what we're going to be looking at is we're looking at what are the restricted values. So what restrictions are imposed on an expression. Okay, and the restrictions are going to fit into a couple different categories. So we'll take a look at this. So first, if we just have a polynomial expression written with nothing else included. So if we just have an expression, is there any restriction on the value of x that you can plug in for this expression? No. So in this particular case, there are no restrictions. Therefore, the domain is any value for x. So the way that you can express your domain is either all real numbers, okay, just a capital R to represent that. This is the inequality form of it. You may also be asked to express it in interval notation. The interval notation to represent all real numbers is negative infinity to positive infinity. Okay, so depending on how it's asking you to represent those, okay, the interval notation is kind of the fail-safe. If you use interval notation, you can't really go wrong with that. All right, now, what if they give you the same expression, however, included after the expression was a specific restriction given? So if they tell you that the expression is 3x squared minus 2x, in addition, x is less than or equal to 5. Well, here they actually include the stated restriction. So you know that the restriction is x has to be less than or equal to 5. That is the restricted value. Okay, so when you write the domain for this, you would write all real numbers, x is less than or equal to 5. Again, recall how the inequalities are entered online. Okay, but you can also enter it, and would probably be better suited to enter it in interval notation. So if we want all the values of x that are less than or equal to 5, would 5 be our maximum or minimum value? If x has to be less than or equal to 5. It's the maximum value, right? So we extend from negative infinity all the way to 5. You never include an infinity in the interval notation, so a parentheses at negative infinity. Is 5 being included or excluded in this set? It specifically tells us that x can equal 5, so it is included, and that would be your interval notation. All right, in addition to expressions and expressions with given fixed restrictions, you could also be given common formulas. So the example would be pi r squared. And so if you're given an expression, and so it may or may not be written in the equation form. So if you're given the expression that is a common formula, so pi r squared or 2 pi r would be some very common ones that you should recognize. There are some built-in restrictions, because when you're dealing with a circle, in order for that circle to exist, what do you know about r, the radius? The radius has to be a positive number, right? It has to be greater than 0. So if you identify that, that's a built-in restriction. It doesn't have to specifically tell you. You can infer that from the formula. So its domain would be all real numbers are greater than 0. That would be the inequality form. If you're looking for the interval notation form, if r is greater than 0, is 0 going to be our maximum or minimum point? Now it's a minimum, so we extend from 0 to infinity. Again, you never include the infinities in either direction. And your 0, is that going to be included or excluded from this set? There is no equal, so it's excluded. Okay, and giving you that interval notation. All right. Next, we have radicals. Anytime you're dealing with an even indexed radical, okay, if you don't have an even indexed radical, then it would fit up in this top rule. Any odd indexed radicals have no restrictions to them, but an even indexed radical does have a restriction. The expression that's inside that even indexed radical cannot be negative. So in order to find your restriction, you would simply set it, the expression 4x or 4 minus x has to be a non-negative value. So it's greater than or equal to 0, and then you'd solve it. Now, there's a couple different ways that you could solve this expression. I'm going to show you the one that helps remind you of a property in working with inequalities. If we subtracted a 4x from, or a 4 from both sides, and then divided both sides by a negative 1, what happens when you're solving inequalities and you multiply or divide by a negative? You switch the symbol around, right? So this becomes 4, or x is less than or equal to 4. So when you write your domain, it's all real numbers. X is less than or equal to 4 if you're writing it in its inequality form. If you're going to write it as an interval, is 4 your maximum or minimum point? So x is less than or equal to 4, so 4 is the maximum point. So we extend from negative infinity to 4. We never include the infinity symbols. Are we including 4 in this example? Yeah, it has the equal to on it. And so that would be our inequality notation, or our interval notation. All right, finally, the last type of problem that we're going to be introducing in this chapter is the rational functions or rational expressions. Anytime you have a fraction and there's a variable in a term of the denominator or in the denominator at all, and there are going to be restrictions to the values of x because you can never divide by negatives. So in order to find the restrictions on a rational expression, you take any factors from the denominator and set them equal to 0 and exclude those values. So here, if we took x plus 1 and we excluded that from ever equaling 0, okay, and then solve. So if we subtracted a negative 1 from both sides, we would get our restriction, or the domain is all real numbers. X cannot equal negative 1. Now, when you represent this cannot equal sign, the way that we're going to do that online is an equal slash equal. So everybody see how that kind of represents an equal with a slash in through it? Equal slash equal is how we will represent not equal to. Okay, so this would be the inequality form of that. If we wanted to identify the form in interval notation, we'd simply take everything from negative infinity to positive infinity with the exception of negative 1. So we would go from negative infinity all the way up to negative 1, but we wouldn't include negative 1. And then we'd extend all the way from negative 1 to positive infinity, again not including negative 1. And if we have multiple intervals, we use a union of sets symbol for that. And so this is what our inequality, or the interval notation form would be for that inequality.
Is that just like a